So welcome to Sustainability Week event, first day of Sustainability Week, and we're here to discuss rewilding the oceans. So if you're not here for that event, then you're welcome to stay. I'd like to thank you all for coming along. It's a pretty disgusting night, so you're very committed. So thank you for coming. And we also acknowledge that we meet tonight on the traditional lands of the Kaurna people, and we respect the people's connection with the land and the sea, and recognise leaders past and emerging. Please turn off your mobile phones. If the whoop whoop goes off, those are the exits, and the toilets are over on the left and right. I'm sure you know the drill. But before I introduce the panel, and we're going to run a Q&A style event tonight, I'm going to give you a bit of a context setting. We understand that we're in the middle of a biodiversity crisis. We understand that the rate of extinction today is the greatest in the history of the Earth. We talk about the 6th extinction that's currently upon us, the Anthropocene, and that is real. We are seeing species go extinct and ecosystems be removed at a rate that we haven't seen before. We've certainly seen very large extinctions before, but those have happened over millions of years, not over decades as we're currently seeing. So, in Australia, Australia does really poorly globally in that context. Australia has the highest rate of small mammal extinction within the world. And the marine ecosystems is also a system where we do very poorly as well. We hear about coral bleaching, we hear about the degraded state of our tropical marine ecosystems. But there's also an opportunity for hope. We're in the United Nations Decade of Restoration. Finally, we've woken up and realised that we can't carry on destroying the Earth and its resources ad infinitum. We have to do something about it. Unfortunately, there is an awful lot that we can do about it. And the panel that's here tonight are going to discuss some of those issues that we can do to start rebuilding some of those really degraded ecosystems. And we think and look around today, and we see invasive species, we see habitat clearance, but if we looked 100 years ago, the systems around us would actually be in much worse condition. And we've actually started that process of repair and restoration over the last few decades, and we're starting to see that process gather momentum. So to discuss tonight how to rewild the oceans, we have an erudite committee that we're going to pose these questions to. Just need to get my notes, hang on. So here we have Professor Sean Connell, who coordinates a multidisciplinary team to look at and solve problems in marine domain. His group was the first to discover that organisms make small adjustments at the smallest scales, the atomic scale, to maintain ecological roles and stabilise ecosystems against climate change. We have Sandy Carruthers, Executive Director of Strategy, Science and Corporate Services for the Department for Environment and Water. She plays a key role in the interface between science, policy and delivery in South Australia, and recently led the development of a research partnership strategy for the department. Sandy has been a key government champion for marine restoration projects here within the state. We also have Catherine Larkin at the end. I'm out of order. Let's do Erin next. We have Erin Pichler. Erin is a PhD student, University of Adelaide. PhD research focuses on how human impacts shape coastal systems. She's a keen scuba diver, and over the last 4 years has been diving on the volcanic underwater seeps of the Pacific Ocean. Geez, I wish I could put that on my CV. And includes winter diving in the murky and rough seas and the beautiful calm oceans. around our coastal marine ecosystems. And finally, on the end, we have Catherine Larkin, a marine ecologist that leads the science and operations at the Australian Ocean Laboratory of AusOceans, a tech startup that focuses on development of low-cost, open-source ocean technology. She's very passionate about how to get people involved within science and also restoration activity as well. So thank you all. Thank you all for coming tonight, and thank you all for coming tonight. So perhaps I can ask Sean to set the scene for us. So Sean, what's, you know, how badly degraded are our marine ecosystems here in South Australia? And what's the thing about oyster reefs? So tell us a little bit about oyster reefs and the marine ecosystems here in South Australia.
Well, oyster reefs must be one of the most degraded ecosystems in the world because they are functionally extinct. Did you know that our gulfs were covered in oyster reefs? When I first realised this, I found it hard to believe. In fact, when I first realised this is when I was looking at a picture of an old steam engine that had been brought out from England to Australia and read an account about how the engineers were re-engineering the carriages on this to move oyster shells around our state. I thought, that's absolutely impossible. And then Heidi Alloway, who was doing a PhD with me at the time and working in primary industries South Australia, found a map in the Department of Transport. And it was one of the first marine reserves in the world where that actually closed off the gulfs to allow these oyster reefs to recover. And what we saw was a map, an old map of the oyster reefs around both of our gulfs. Where are they today? Gone. Sand. Replaced by sand. That is the eradication of an ecosystem. How impressive is that in a negative way? That doesn't get much more than that.
So, but Sean, these aren't Pacific oysters that we eat in the shops. These are native oysters, aren't they?
That's right. They're the native flat oyster. So the oysters that we're famous for are the Pacific oysters, which come from Japan, that we grow up here in quite beautiful waters over on the west coast. But the Pacific oysters are quite different from the flat oysters, which actually reef build here and create habitat for fish and are kidneys for our ocean.
So what did we do with the oysters? Did we just eat them to death, or did we use the reefs in other ways too?
Without oysters, I don't think South Australia could have been colonised. The accounts of the first tall ships that came here promising people an abundance of life and food was actually quite miserable for them because they didn't find that. To sustain their lives, they ate oysters. They ate abalone that were crawling around the intertidal and crayfish. Now those things today are actually delicacies, but we actually ended up annihilating those stocks. It wasn't just for food, but also our road. If you look at some of the old villas around Adelaide, and you look at the mortar and the plaster, you'll see that that's actually the crushed up oyster shells, turned into lime, burnt, turned into lime, and used for roading. In fact, that's why these carriages were being modified to carry tons and tons and tons of oyster shells around our state to get it going. Infrastructure.
So well done, South Australia. We completely destroyed a species and the ecosystem that it generated and supported. Not a lot of people know that, do they? But you also recognise that there was a chance for those ecosystems to come back. And Sandy, you know, Sean published some of this work in scientific journals. You know, we had a historical context about that. It was a call for help, really, to actually be able to go and restore those systems. How does state government get behind those kind of initiatives and understand that they really need to be done?
So, thanks, Andy. So I might just I said before that shellfish reef restoration was almost an accident, but I think it was probably more a happy coincidence. So just to give you some background, when marine parks came in, recreational fishers, the government wanted to provide some additional recreational fishing areas, and so there was an election commitment to build an artificial reef, which means ties and concrete in the water, which help fish aggregate, and then there's somewhere for people to fish. But as it so happened, Heidi Heidi happened to be the manager of the group that was going to build that artificial reef, and she was doing her PhD, and she realised that the shellfish reef used to be here, and she had been talking to the Nature Conservancy, who's a big NGO based in the States, and they do lots of shellfish restoration. So she came up with the idea with Sean of, well, instead of spending the money on tyres, why wouldn't we build a shellfish reef and create a habitat that's sustainable and that will actually grow fish? So, and that's kind of when I met Sean and Heidi. They came to see me and said, "What do you think?" And because the department was obviously running that, so it sounded like a great idea. And I think that's really where it started. So it was kind of the money was there to build a reef, and then we just decided that we would talk to the community about, well, maybe we don't build an artificial reef, maybe we build a shellfish reef that will be something that's sustainable. And the community loved it. So we when we did a yaw say across the state around where do people think we should put the reef, and we had so many people write in and apply. So that's really how it started. And then I guess the other thing that happened was we had $600,000, and that was enough to build something small. But what we did with TNC is we held off, and we tried to get money. We tried to get money from different places, and in the end, they were successful to get $1 million out of the federal government because we'd held the other money back. And so then they were able to put their own money in, and we were able to build sort of a 20-hectare reef rather than a 4-hectare one. And we did the same thing with Sean. So we provided Sean with a couple of $100,000, and the uni also kicked some money in. And Sean said, well, can we just hold off and we'll see if we can get someone else to come in. And then Ian Potter Foundation came in and doubled the money. And then we had a really nice amount of money for Sean to actually start the science, because from a government perspective, we wanted to make sure that you had an evidence base around what we were doing. So we didn't just want to spend money and assume it was going to work. We wanted to make sure we set it up with really good science to inform what we were doing. So, but that's how it started. It was kind of a happy coincidence really at the beginning that we met, and that was 8 years ago. So it was a long time ago, and it took us 3 years to get the money. Yeah.
So I was going to ask how long it was. 8 years, and there's some key strategy points there. So instead of putting tyres in the ocean, which is often what's used as substrate to rebuild reefs, you actually went, a key decision was made around let's put back a functional ecosystem and let's try and do that. The other critical piece was a coalition of the willing were built together, and you held off spending small money and kind of snowballed it into a major initiative and then launched it. So look, it is a pretty impressive story coming from kind of the massive degradation that happened for those ecosystems. So I might just go to Erin now. So Erin, you're a PhD working on the project. You're one of the people that's kind of challenged with rebuilding these kind of systems. So you're kind of repairing the sins of the fathers, basically, aren't you? So how do you rebuild an oyster reef and ecosystem? No pressure.
Personally, how do I do it? Well, what the TNC did was, the first thing is to actually create the reefs. So they got locally sourced limestone boulders, and like Sandy said, they were put down instead of the tire reefs. And they got oyster shells, and they seeded these oyster shells with baby oysters. And that kind of becomes the first point for these reefs to start to build up.
Where do you get baby oysters from?
That is a good question. Sean, where do we get our baby oysters?
They had a hatchery, and so they put shell into a hatchery, and the little babies settled onto the shell, and then you take the shell out and scatter them across the reef.
Oh.
So the divers went down and scattered these oyster shells around the reefs, and that's where it kind of begun. And once you have that base and that structure for those oysters to grow on, you're able to kind of get things going. The biggest thing with the reefs is going to be monitoring. If we don't have that continuous monitoring and getting those baselines, then we can't see how they're progressing, and without that we can't see how to make it happen better. There's been some research that's done on attracting the baby oysters with sound, and the sound that they're attracted to is healthy reefs. So a healthy reef has snapping shrimp, which snap, and this sound is actually a queue for oysters, baby oysters called spat, to come in and to settle on these reefs. And so some initial studies have shown that we're going to be able to use those sounds to help continue to grow these reefs. I also think the direction of research and how to kind of build these reefs faster, larger, all of that is going to be multi-species and multi-habitat restoration. And also going back into ecological theory. So how we can alter maybe the shape of these reefs to create these oysters to come in and build them faster. And it's a really cool, exciting opportunity to, hijack that restoration and get it going.
So you can have an army of PhD students employed for future years. Don't worry, Sean, your career is safe now. Look, that's really important. And you talked about a few key elements. You talked about, getting the substrate right, and you also talked about, you play sound underwater? Do you actually play that sound?
So the first part of that research was done in the labs. We're hoping to potentially do some sound studies out on the reefs. But so far in the labs, what we've found is, it was someone else's research, not my own, but what was found was that you would play the sound on one end and have no sound on the other, and those baby oysters, when placed in the middle, will head towards the sound. They actually swim directionally.
So I think Kath sitting next to you is one of the key people who enabled us to play music underwater.
So Catherine, let's have it. What's the role of technology here? Go on.
So Sean's lab approached AusOcean looking for a novel way to play sound underwater. Commercial speakers, I think the one you have costs around $1,000. 3,000. And part of what AusOcean does is build low-cost technology, and we have a whole bunch of really smart engineers. So they got behind the problem, and within about a week, we had a speaker prototype that cost $60. It probably doesn't play quite as loud as the $3,000 one, but we were able to do experiments. Our first one we did on Windra Reef, which is the first reef that was ever built in South Australia. And we got some phenomenal results from that, which was really exciting. I think that was the first experiment that we did in the field. And since then, we've done another experiment at Glenelg, which also, Sean, you could probably talk about the results from that, which I think are pretty exciting. Can you talk about them yet?
I can. So I lost a bit of sleep over this because, as Erin was talking about, we were putting rock into the ocean, and we were hoping that we would just bring oysters back. And the costs of using a hatchery to bring the oysters back is really quite formidable. And what was facing us was having to do that year on, year out, for about a 10 or 15 year period we were estimating. And so I was open-minded to anything that could bring oysters back. And playing underwater music was the idea. There's a few weird things I read to get to that point, and I remember speaking to my Dean of Science saying, you should give me a go. And he said, no, Sean, why don't you just dangle some crystals under the water? He thought it was mad. But these engineers didn't. And I was able to convince them that these larvae, these little specks in the ocean with little cilia around them, little tails, could actually make decisions and migrate and move through the water column in this hearing sound. Now, they're not like us, where what you're hearing right now is vibration pushing against your eardrum, sound pressure. What they detect is particle motion. So it's me hitting a molecule, which hits another molecule, which then hits you. It's like bullets. It's highly directional information for something navigating through the water. And so Kath and her crazy engineering crew thought this was marvellous. And we were able to carpet Glenelg Reef with these low-cost speakers and increase recruitment from minute numbers to 1,000-fold their natural numbers that were coming through. So we are looking at being able to rescue reefs which are built into the future, using this really high-tech, low-cost technology with these guys, and have the blueprints put online so that schools, and I think Kath can talk about the school part here, and people around the world can go to their local Bunnings. And perhaps, Kath, you could talk a little bit about how we try to enable Australia, if not people outside Australia, to actually use this technology.
Yeah. So hang on. We've got an academic made friends with government, so joined forces, and now joined by a startup. So we're starting to get industry and startup money involved. And the technology piece. Hang on. Can we just so the technology piece isn't only around sound, is it? It's also about visualization. And the cool thing about this is it really gets people interested, doesn't it, Catherine?
Yeah, that's right. So this is a live stream that we took at Glenelg Shellfish Reef with one of our low-cost underwater cameras. So we know that video is a really great way to engage with people and the oceans. Not everyone is a diver. Not everyone wants to put on a 7mm wetsuit in the winter and dive down onto the reef and have a look. So we can use underwater video to connect with people en masse. So we have a few underwater live streams that stream live to YouTube. And they reach the world. We've had people from over 40 countries watching these live streams, over 5,000 hours of video watched. We had someone from Germany saying that these videos should be played in the doctor's waiting rooms as opposed to TV. So that's what we want. We want to have these live streams.
Can I just interject here? Kath just about crashed SA Health. Apparently all the health professionals in the hospital over here were watching this on their computers instead of doing their job.
Yeah, wouldn't be the first. Even myself at work, I find myself procrastinating on the live stream, seeing what we can find. It's really good. It's also for our students that are involved in our school program, Network Blue, for them to see tech that they've built, because they build these underwater cameras and they build our low-cost research buoys, and they see them in the ocean. It's really, really empowering. And then they can actually watch these streams in the classroom as well. They get to learn more about their local environments, which is really special.
So how many schools do you have involved in the program? How many community participants?
Yeah, so at the moment we have about 8 schools, and we're bringing some more on in 2023. One school that we're really excited about is Kangaroo Island Community Education. Hopefully they're going to come on board early next year, and they'll actually build one of we call them rigs. They're a low-cost research buoy, and hopefully they will build one and put it on the new Shellfish Reef on KI. So they'll be one of the first schools to test this new Shellfish Reef monitoring that we might be able to scale up. So that will have a camera and a hydrophone, so ears and eyes on the ocean.
And how many? So this is footage here from Glenelg, is that right?
Yes. Yeah.
How many reefs? How many reefs are there that you're rebuilding around South Australia?
I could guess. 4, 5.
So at the moment we've built a 20-hectare one at Windra on York Peninsula. We've got one at Glenelg. There's one at Onkaparinga. There's a 5-hectare one going on, about to be built at Kangaroo Island, and then 2 smaller ones there as well. One by the council, and one by one by Flinders and one by the Landscape Board. So there's enough in different places now that are big enough that we can really do some, I guess, understand how they're functioning. So and Windra is still the biggest one in Australia. And the money for the Onkaparinga and the Kangaroo Island reefs came out of a federal government funded called Reef Builder. So when they gave us the first $1 million, they were like, oh, this is weird. We'll just give you a bit and see what you do. And then by the end of it, they kind of went, oh, it's a real thing. And because we had built a 20-hectare one, I think that gave them confidence to provide $20 million to go across Australia. So, yeah, So
hang on. It went from 600,000 to 20 million. And it went from South Australia to national. And you've now precipitated a rebuilding of the reefs, the southern temperate reefs around southern Australia. And you guys can claim you started that. Nice.
Yeah, I think Victoria started, but theirs was tiny, and then we just went, let's go big. Go big or go home.
Go big or And so, Erin, just back to you. You're a keen diver, right? So you've notched up over 100 dives on some of these reefs. About that, what's a few dives between friends. So what are you seeing there? So we can see the video here. What are you seeing when you dive down? What are the changes that you've seen over that time that you've been diving?
So I think the coolest thing, I've been diving at the reefs. I started at Windra and I was there when that was built 4 years ago. And then I had a bit of a break, and then last year, a year ago, I started doing some research at Connell and the Windra Reef. And so I think the coolest thing is the annual changes that you see. I guess it wasn't something that I had expected to see. It's kind of like the seasons as we see them out here. Things change annually down there as well. So in summertime you have, I think I just saw them up there before, the blue swimmer crabs. And they pester you while you're trying to count oysters underwater or get the turf cover. Or, you'll look up and you'll see a school of thousands of Tommy ruffs just circling around you, which is really beautiful. And I see cuttlefish, squid, there's oysters down there. And then in winter time, you get the seagrass rack accumulate on the edges of the reef. And the big flathead come in from the deeper waters, and I saw the biggest flathead I've ever seen the other day. I think, it's just really amazing, the abundance and the variation of what you see there. The weirdest thing I saw there was something called a sea pen. I've never seen a sea pen before. And it was this, nearly a metre tall kind of solitary weird thing that looked like it was from a sci-fi movie, from Alien or something. I was shocked by it. It's really, really beautiful down there. And I think for me, that's telling to where this might be able to go with ecotourism or something like that, because I'm sure I'm not the only person that's interested in all of that. And again, great to see all the fish out there for the sole purpose that the reef was originally built, which was, to give back to the fishermen. It's beautiful.
So you started with oysters and oyster reefs, and then slowly what's happened is it's been colonised by a whole group of other species, and you're getting these additional benefits as well. So food for oysters. Why don't we eat native oysters here? Can I buy them in the shops? Ngazi oyster, isn't it?
Yeah.
That's right. It's we can compare it to beer. So your Pacific oyster is a bit like your very cheap West End ale. It goes down quite easily without you having to think about it. But the native oyster is a bit more like a craft beer. You put it in front of you and you go through it slowly and you enjoy the much more enriched and complex flavour. And you can't really start off with a craft beer, can you, when you're starting out from drinking? You do approach it through those more bland ales. So it's an acquired taste.
We should have had some tonight. We should have served some up. Anyway, so Sandy, a really important part of this project is actually having a science base, isn't it, to the work that's undertaken? So, and why do you think this project was possible here in South Australia, and then kind of spread out from here to have national coverage? What is it about South Australia that made this possible?
So I think the science was really was the critical bit, because it was the research. So I think people, it's such a great story for people to think within our memory that entire system was lost. So I think it kind of captured people's imaginations. And then I guess because the Nature's Conservancy had been doing restoration in the States, they actually flew their specialists over and they did a lot of talks with councils and a lot of people that they thought would be keen. And so that kind of cemented the idea that it was possible and that we could do it because someone else had done it. And I actually think in the end it was just that we all backed ourselves in, because I think the other states had a lot more hurdles to jump through, and we just kind of, as government, we said, no, we want to do it. And so we didn't put hurdles in the way. And I think the biggest risk around Shellfish Reef was really the biosecurity risk. So not bringing POMS in, because POMS is a virus that kills the Pacific oysters, and we didn't want to do that. So PIRSA were really heavily involved in making sure that we did everything the right way. We didn't bring barges in from Victoria which might have had POMS on them. So there was a fair bit of checking to make sure we did that right, but it didn't stop us from doing it. And I think the other thing is our oyster reefs are very deep, so they're sort of 6 to 8 metres down, and they don't interfere with boats, which is really important. So in the eastern states, they're intertidal, and that just causes you can't go sticking stuff in the boat zone. So I think there's a bit of like the fact that they can go deep, which means no one minds, and then the fact that people are kind of happy to know that this could be put back and that we might get something out of it. So I think the fact that the science demonstrated we could do it.
And so, why aren't we telling the world, Sean? Why is, so this is such a success story. It's gone from here in South Australia, it's gone national. Are there other projects like this around the world? And why don't we know more about it?
There are projects in the United States, so the biggest reefs are in the United States. I think what's really unusual about this is that we have gone from sand, we've gone from extinction to something which, if you look across at a Drossen, that 20 hectares is spread over a kilometre more than. That's a ribbon reef. When you think of the Great Barrier Reef, there are a lot of ribbon reefs. So that's a substantial functioning structure that we've brought back. So that is a world first. Why doesn't the world know about it? Why doesn't the world know that the South Australian government was the first government to give women the vote? Why is South Australia so modest when it comes to these pioneering social and environmental issues that we aren't known for them? I'm not sure, Andy, how we get the message up there. I think we need to market ourselves a little better.
We need more YouTube subscribers, so subscribe to AusOcean.
So maybe we can help provide the link to the YouTube feed after the talk. Now,
Yep.
Catherine, what have you've got something by your feet? What is that? Take us through that.
So I brought some show and tell so you can kind of gauge what kind of tech we build. So this is one of our underwater cameras. This one will deploy at O'Sullivan Beach shortly, actually. So it's made out of PVC pipe. It costs about $200 to make. A lot of the parts inside are 3D printed, and this is actually on the end a new 3D printed underwater connector that we're testing at O'Sullivan Beach, which will be revolutionary for us to deploy. So I'll pass it around. You can have a look inside. Just don't break it because we have to deploy it.
So how much does one of those cost to make? What are they from the parts?
Yeah, so about $200.
And how many of those would you deploy, or are you aiming to deploy?
Yeah, so at O'Sullivan Beach, we're hoping to put 2 down. One of them, we're actually running an experiment. One of our interns is working on some computer vision correlating turbidity with visibility. So we're actually going to try and share live visibility data on our live streams, which will really engage with the diving community, because if you're a diver, before you go out and dive, you want to know how good the conditions are. But not only that, for researchers, turbidity can be really important. So that'll be really exciting to see how that goes out there as well.
Look, it's a great story that you guys have been telling tonight, and I think Sean, we should certainly help to promote this story and see the recovery of a system which was basically lost, but then can be found. And I think the great thing about this story is, even an ecosystem that's lost from a location can be rebuilt before it's too late. I think we have a time within the next 10 or 20 years where with these types of initiatives we are able to recover and restore these ecosystems. It's important that we're in the decade of restoration supported by the United Nations, because this is really a time where we can motivate action, and you can see the results of these from a project here in South Australia. But really the nice thing about this project is also the demonstration of partnership, and partnership between a number of different players that have come together, have understood what is possible, what is achievable, but then broken it down into small achievable components to actually deliver those, and to buy in additional partnership and support. And also the role of a combination of science together with technology and community. And arguably, without those three, you wouldn't be able to get a project of this type. So certainly we should be promoting this internationally for a restoration of the ecosystems. And before I met with the team here, you know, I thought reefs was all around the Great Barrier Reef, and I had no real understanding of the reefs that we had here within South Australia and their importance. And basically the support for that. So once you restore these types of reefs, you're able to bring in additional revenue. You're able to, as you say, bring in ecotourism as an option. As you get colonisation by plant and algal forms, you also get increased carbon sequestration. So we're also getting these ecosystem services from this type of system. So, and it's amazing complexity that can be built, but it doesn't just rely then on grant money. It relies, so grant money is required to start these projects, but then you have a self-fulfilling kind of momentum that's generated to help these projects achieve additional scale and then broader application as well. So we can take some questions from the audience tonight, but did any of you want to add anything before we move to the audience? All good. So this is a chance for you guys to ask some questions of the panel. I think we've got a roving mic, do we? Maybe swap it with Erin. And so we're happy to open it to the floor and ask any questions that you want. It doesn't need to be about oyster reefs. It can be about other marine ecosystem and restoration projects, or it can be about another challenge that you know about. So happy to take any questions. We've got one down here at the front. No? Yeah. If you wave to me, I'll help Belinda find you guys if you want to ask a question. Yes, sir.
Hello, I'm Mark from Friends of Gulf St Vincent. I'm interested in the water quality issue and whether or not you think oyster reefs can make a significant impact on the water quality in South Australia, in the Gulf St Vincent.
Sean, do you want to have a go at that? And then we can maybe get Erin to.
The reason why that's a good question is because we know historically that places like Sydney Harbour were crystal clear, and the loss of oysters in that harbour meant a loss of filtration, which meant that the water clarity was lost, and the ensuing pollution problems that they have today. That's been stamped across the world. You look at Tasmania, it's the same with the Duat estuary. And here, if we can get it back to that kind of scale, we might be able to get back some of that clear water quality. That is going to be an intergenerational project. Very keen to partner with big business and say SA Water, which sees that putting in these reefs in the near shore could bring back the seagrasses, bring back the water quality. Remember, SA Water is a place which actually has wastewater treatment plants. They need to license and discharge our waste. This kind of project as a natural solution to some of the problems of our waste could be fantastic. And instead of paying the last 800 million we have paid in our wastewater utility bills, SA Water bills, that could go a long way to bringing these ribbon reefs back up and down our coasts.
So another ecosystem service that could be provided. And are you seeing kind of murky waters down where you are? Is that a problem where you are?
Yeah, well, the Friends of Gulf St Vincent have been conducting a citizen science project looking at water quality issues in the Gulf, mainly around the metropolitan area. And it's really hard to gauge over those sort of scales and timeframes, but certainly, you know, we can all see stormwater impacts every day when we go down the beach. But yeah, so I was just wondering if we can determine scientifically if there is a significant opportunity for oyster reefs to improve the water quality.
So I might go to a monitoring question and some of the technology that could be deployed. Sounds like an opportunity for AusOcean, I think.
Yeah, absolutely. I was going to ask Sean, actually, what tech do you want us to build? What would be beneficial to monitor? We can do sound, video, temperature. We're working on turbidity.
It would be the optics around measuring nitrate and nitrogen, the different species of nitrogen. I think you guys could probably do so. It's very, very expensive. So
Yeah.
you guys are probably the best people to talk to.
Cool. Yeah, we'll look at that then.
And Sandy, you're also responsible for implementing some of the scorecards for environmental condition here within South Australia. Is water quality within marine systems, is that part of the scorecard?
That's a SA Water. So SA Water do all of that with the EPA. So that's what I think. So Sean's been talking with them around how they could. The idea is that shellfish reefs should be able to filter water. So if you see TNC have, I went to a meeting where they had an oyster in a fish tank, and the fish tank was completely turbid, and by the end of the meeting it was completely clear. So oysters actually do completely filter everything out, and they collect it in their actual shell, and then they expel it as an actual product that's useful for I think I don't understand this as much, but it's actually useful in the actual ecosystem of the reef. So they do clear water, and they're amazing, but it's about how do we set them up for scale and in the right spot so that they can do it. So, but it's definitely on the cards. Yeah.
So yes, oysters can do it. Needs to be done at scale, and we should have cheap and easy monitoring technologies that should be able to measure that over time. So watch this space, I think. Any other questions? Oh, we've got a few coming now. So take one there, guy with the scarf, and then the guy in the hat.
Hey, really great project and awesome technology.
Introduce, give us your name and where you come from.
Josh, I'm an environmental policy and management student at the uni here. So yeah, I'm just really curious as to how the hatchlings detect the specific, how the particles move. Like how do they detect specifically how the particles move? But also, measuring the carbon sequestration, do you have to get samples of each specific species in the reef, or how is that done?
So how do baby oysters move around the reefs? How do they find the right location? Who wants to take that one first? And then we'll do the carbon sequestration question.
When I first spoke to my students about this, they thought I was crazy as well. So I said, why don't we just set up a racetrack in the lab? And so about the size of this bench return, we created a racetrack. And we played music at one end of it.
So what music did you play? Bit of Vivaldi or Iron Maiden? What was the choice?
We actually played snapping shrimp noises. We're going to get an iTunes list on the best music to play to bring back oysters. That's going to be a cool project. But we found that they did move. They moved towards the music that we were playing. And I had a student that was interested in physics. I didn't know how physics works in with this, but he researched what it was about the properties of sound that interacts with biology and quickly told us that we were deluded because we were thinking about sound in terms of our ears, wave pressures, and these things weren't responding to that at all. And the wavelengths that they are responding to are not measurable by current day equipment. There isn't the technology to measure what they're responding to. So that is a whole new field that we'll need to develop in the marine science space. So we can play noise, but we can't measure it. And what it is if I fire a bunch of bullets in a straight line, that's like the molecules hitting each other, and you can feel it hitting against your soft parts. And that's what we think they're responding to. But only last week, one of my students said, I think I've discovered an air in these baby oysters. It's a paper that was written in the 1930s by a French scientist that she's just discovered. So this space is wide open, and my view on it's changing daily.
Wow.
Great. And for the carbon question, Sandy, are you because carbon sequestration and the carbon economy is now upon us. We've probably heard more about the carbon economy on terrestrial systems, tree planting and soil carbon, but marine systems are also a really important carbon sink as well, aren't they?
So the carbon sequestration's not huge in oyster reefs. That's not one of their main things, but the seagrass that are around them and everything do have carbon. So I think once you get a reef and you get the seagrass back in, then you start to get the carbon that you want. But in terms of the reef itself, it's not a big component of it.
So it's not the oyster reefs, but it's the seagrass and the other species around that. Thank you for the question. We have another question here. Belinda, guy in the hat.
Sorry. Yeah, just. Is that on? Yeah, I'm wondering if there's any ramifications of the oyster reefs for beach sand management.
For beach sand management. Yeah.
Yes, we're very aware of that space, and the project that we're currently working on is the design of the reefs in terms of their profile and what that does for buffering wave energy as it goes over. So we are in partnership with Flinders University in their oceanography department, as well as SA Water, to look at how they can act as a brake against the disturbance they create physically on the bottom. So that brings back the seagrasses, because they're so highly disturbed they just can't come back naturally in our nearshore zone. And also the insurance industry, I would imagine, would be incredibly interested in the houses that wouldn't fall into the water as a consequence of erosion by using these natural solutions in the ocean. There's a long way to go on that, but we're certainly aware of it.
Any other ones? Great. Bronwyn.
Yeah. I'm just wondering about the permitting process to put these reefs out. Like, you've mentioned DEW and you've mentioned PERSA, but is a whole of government type, like, do you have to go through every government department? And just wondering how long it took to get the initial reef out there.
So who's responsible, Sandy?
So that's a great question. So the first reef took the longest because we had to get a development approval to put. So basically, Department for Infrastructure own the seafloor, and if you want to put anything on the seafloor, you need to get permission. So we spent a long time working with them, with planning, on the first application to make sure we did it the way that they wanted it. So government did the first application, and that's when the idea that they're deep was good, because it meant that it didn't interrupt any kind of boat movement. So that would have been a big showstopper, I think. So we did that one. That took a long. The first one took a while. I think it probably took us a year to get it right, but that was fine because we were getting organised anyway. And then all the others have been very quick because we've had an agreement with them. This is how we do it. They understand what it is. Government has sponsored it to date. What I'd like to do is get local council to be confident enough to put their own applications in. But we'll work towards that. But yeah, so we knew that would be an issue, and we paid attention. And then because we did it the right way, it hasn't been a problem for the next three that we've done.
And I guess you also showed that it wasn't that risky. So you de-risked it by demonstrating.
And it's pretty low risk. I mean, it's limestone on the seafloor. It's not, and it's quite, with the way that it's been constructed, it's quite solid. It's not going to move. It's not going to move in a storm. So, and even if it did move, it's just some limestone. So it's not a huge problem.
And the nutty biologist here again, who plays underwater music, looking 5 years into the future, 10 years into the future. The reason why I'm working with psychologists, social scientists, and legal scholars is to see whether or not we can make this process smoother and more easier on the public and government, such that when big industry or whoever you are want to restore, we can, as a community, including big business, can actually get these reefs out at a scale that matters to, like, the people, the friends of the St Vincent Gulf. Because otherwise, if it falls on the shoulders of people like us, we'll still be here in 50 years' time with a few ribbon reefs.
So how many kilometres of reef is waiting to be restored?
Is it 1,200?
1,200 just in South Australia?
Well, it used to be 1,200 worth of area.
So here in South Australia, what about in Australia? Thousands of kilometres, and globally, what are we talking?
Well, we've lost 85% of our oyster reefs globally. It's an astonishing thing to be able to bring back.
Thank you. I think we had a question down the front here. Sorry, Belinda. Thanks.
Thank you. I'm Paul from Global Edge. I'm fairly excited about the genetically modified canola, which produces, which contains long-chain omega-3 fatty acids. and my interest is mostly human nutrition, but I do believe it's felt that in terms of marine aquaculture, this product, the terrestrially produced long-chain omega-3 fatty acids in canola, can be a source of taking pressure off native fisheries, for example, by feeding directly caged salmon these genetically modified canola instead of catching large quantities of small native fish to feed larger caged marine fish. And I just wonder if you people sort of share some enthusiasm and whether think this can be quite significant in terms of basically restoration of or protection of the marine environment.
So I think, Sandy, do you want to have a go at that? No, I think. Anybody else want to have a go? I think I'm happy to have a quick go at that. I think certainly diversification of food supplies are important. And I think the more that we can relieve pressure on natural systems, the better. But also, I think with some of the systems that we have, there's probably there's always a spectrum in a landscape, right? So there's the do not touch conservation approach, and there's completely deplete it and use it kind of approach. And often to demonstrate value, there's often components of systems that do need to be sustainably used because they also demonstrate value. And that's part of the restoration and the conservation case that needs to be made. Certainly those populations need to be large enough so that they're self-sustaining. And we talk about, 30% of the land area needs to be native ecosystems because there's plenty of other land for food production. But without getting that balance right, then we're going to offset those systems. And being able to relieve some of the pressures on marine systems through terrestrial production is surely part of the solution. Any other thoughts? No? Okay, we'll take one more question. Lycian. Oh, we'll take two more then. That's fine. Lycian, you'll have to wait a minute. There we go. And just shout out your name as well, please.
Yeah, my name is Yawen, and I'm doing a Bachelor in Environmental Policy and Management. So I know that climate change is a really huge issue, and it's also causing ocean acidification, which affects calcifying organisms, and oysters is part of that. Like, I'd like to know what kind of projects are you guys doing to combat that issue?
So ocean acidification, I think we have somebody here doing their PhD on a kind of topic not a million miles away from that. So Erin, I might get you to have a go at that one.
So I have a twofold kind of thought with this. The first one is that's definitely something I've been thinking about. I'm thinking about ocean acidification with oysters. The ocean acidification work that I do is with sea urchins, and they're not too dissimilar, I guess. I think
what's the problem? I mean, what's the problem with ocean acidification for shellfish? What's the challenge there?
So it causes their shells to dissolve. It makes it more difficult for them to survive in the ocean, and by making it more difficult for them to survive, it means that they might prioritise building their shells as opposed to growing their reproductive organs. And without putting that energy into their reproductive organs, maybe they're not going to produce as many offspring, and you might see those populations diminish. I think that my work with urchins isn't completely transferable, but I do know that ocean acidification also increases the CO2 in the water, and more CO2 means more algae. And I don't know if there would be a filtering kind of component to that, whether the oysters would be able to buffer against ocean acidification because they filter and they're eating those components from the water column. I don't know. I think it would be a cool place for research, but I personally don't have any exact kind of answers, but yeah.
So you've got this feedback loop, right, haven't you? So you've got carbon dioxide, which is released, it then dissolves in the ocean, it drives more acid conditions, breaks down the shells, then release more carbon dioxide, and you get this cycle. So probably the way out is to stop fossil fuel emissions.
That sounds good.
And to reduce, that sounds good, doesn't it? To reduce carbon dioxide levels, then that probably is the only way out to stop this ocean acidification.
Yeah, and I think to touch back on that, if we're making the work that we do more well known, and we're passing this lust for nature onto people preceding us, then I think with one, the other comes. Once people start becoming aware and excited about restoration efforts, then they can also see tangible results of why we should be, reducing our carbon output. And yeah, I think it's cyclical in that way as well.
They can see it in their doctors' surgeries and waiting rooms. Yeah, we should do that. Okay, lithium. Sorry, Belinda. Oh, yeah, there we go, got it.
Hi, Lysiane from the Department for Environment and Water. I'm just really interested in, the scaling up and the next stage of what we're going to do. You've talked a little bit about getting industry involved to be able to do that. I'll be interested in the panel's thoughts around, what are those big challenges and what can we do to get more of these back?
Yeah. Maybe, Catherine, do you want to start at this one? Because obviously AusOcean came on board. Alan Noble, who used to be with Google Australia, set up this kind of NGO, which is AusOcean. Why did you guys get involved, and what do you think are the opportunities to bring other kind of industry kind of partners along in this?
Yeah, so I can probably talk about the tech, not so much the scaling up of the actual reefs. But Erin, you mentioned earlier, one of the challenges with monitoring these systems is continuous monitoring, and that's one of the main things Sean came to us with. Was we need eyes on the ocean at all times. So what AusOcean has done is developed tech that operates 24/7. So our research boys are connected to the internet, so they're sending data in real time, and that means that we can actually get some of this continuous data that you might need to ensure the longevity of these reefs. So I mentioned a bit earlier Network Blue, our school program. Hopefully a way we can scale up the monitoring, at least of these reefs, is through schools, getting schools involved, local community groups and partners who can build these research buoys, and we would have a network of data flowing in, built through schools and communities that reside close to these reefs. So that would be really amazing.
So it's about building a network of partners that can bring in new skills and offering those opportunities. How else can we upscale, Sean?
I might be repeating myself, but the reason why I'm working with lawyers, scholars, social scientists and psychologists is to work out how the public would accept big industry, how we would be able to facilitate that through policy changes, legal challenges, changes to the legislation, so that we simplify and make it more accessible for people to be able to, whether they're small or big in terms of corporation, put out these reefs and invest in those reefs and see a return on it. If you're an abalone fisher, for example, and the abalone stocks are declining rapidly in South Australia, we're the biggest producer of abalone, incidentally. If they can see benefit in building these reefs themselves so that their stocks can recover, that would be fantastic. But at the moment, the legislation blocks us from doing that. We need to make it simpler. But at the same time, we need the right handbrakes so that we don't bring in things like biosecurity issues that Sandy's been talking about as a plague on our state. So there seems to be a lot more of work that needs to be done in the non-biological space and more work done with the humanities to allow this to happen.
I'll just say there, Sean, that sounds really amazing because AusOcean wants to build our own. So AusOcean wants to build our own reef at Oka Point. So we could be a guinea pig if you want to get that done.
So there you were. You were there that the idea was born and started. So we're stimulating new partnerships as well here tonight. Well, I think we've had a pretty special Q&A session tonight. So thanks very much to Sean, Sandy, Erin, and Catherine. Please show your appreciation for a fantastic discussion tonight. Thank you. And I think we have the room till 7 o'clock when there's going to be a celebration of, I think, a 50-year anniversary, but not to do with us. If you'd like to stick around, the panelists will be around to answer questions. Catherine, I think you need to retrieve your camera somewhere, wherever that went to. Yeah, we'll be sticking around for the questions. So thanks very much. And thank you all for coming out on a cold, wet night. Thank you.